Hey guys, Mr. Pike here helping you out with math and stuff. Alright, in this one we're going to be talking about factoring. Now the fun really starts. Alright, so I have these kind of laid out for you guys. If you see like x squared plus 2 times some number plus a squared, so essentially what I'm looking for is x squared plus 8x plus 16. If this number squared, square rooted, sorry, so like 4 times 2 is 8. This is called a perfect square, a sum of squares. So perfect square would be factored as x plus a squared, whatever that number may be. This stuff we'll kind of see as we go through it. Really the only special case you need to be looking out for is the perfect and difference of cubes equations. These take a little bit of practice, so I would highly suggest you write them out as much as you possibly can as you are doing these. So if I see x cubed plus some number cubed, so that would be like x cubed plus 2 cubed, which would be like 8, which we'll see how these work as well. The way that this works on this other side is I would have x plus a, in this case a is 2, times x squared minus 2x plus 4. Notice that's with a plus, and a plus had a plus first and then a minus there. If it were a minus, it has a minus first and then a plus there. So everything about these equations is almost exactly identical except for the signs right here and right here. Everything else about them stays the same. So factoring is just getting two things that multiply to each other to make this. But if we have a plus, and then a minus. If we have a minus, it's a minus and then a plus. So I think some people say like keep change or something like that. I don't know. But this is going to help us out in factoring. So with something like a here, right, in all these examples, all we're going to be doing is factoring. This is going to go super fast because really factoring is not that bad. So if I see this, if you're not sure and you don't recognize this as a perfect case, remember you can set up your factors, and it's two numbers, the numbers that go in this spot and this spot, multiply to be 49 and add to be 14. So the only things that multiply to be 49 are 7 and 7. They also add to be 14. So you need to rewrite this as x plus 7 squared. If you can jump straight from this to this, go for it. I'm going to start doing that as well. Multiply to be 49, 7 and 7, add to be 14, 7 and 7. Right? So it's the same number. So with part B here, this is a difference of squares, right? Because we had x squared minus a squared was x plus a times x minus a, because it's a difference, a subtraction of two square terms. Right? So this is x squared, this is 4 squared, so we have x plus 4 times x minus 4. That's it. That's really all there is to this. This one is a sum of squares because I see 81 and I'm like, well, that's 9 times 9. And then 9 plus 9 is 18. And notice since it's a negative, all that does for us is we want to do x minus 9 squared such that negative 9 and negative 9 would add to be that negative 18. Moving on. This x squared, that is 5 squared, so it's a difference of squares where we have x plus 5 and x minus 5. That's it. That's how you factor it. That's it. Super fast video. This one is actually not factorable. You'll learn, yeah, let's not talk about this now. We can actually factor this, but it's kind of weird. So later on in this chapter, we'll get into something called imaginary numbers. But for right now, we'll just call this not factorable. Because this is a sum of perfect squares. However, we are missing a middle term like we had up there. We had that minus 18x. This would be 3 and 3, so we would need something like x squared plus 6x plus 9 in order to actually factor that. So since we're missing that middle term, it doesn't factor. All right, so here's our first difference of cubes. I notice it's a cube. That tells me it's a cube right there, that x to the third. So I can look at this as x to the third minus 2 to the third, right? It's a difference of cubes. So if I have a minus, I know my first factor is going to be minus, and then I'm going to take the first term squared, opposite sign, so plus the two terms times each other, plus the second term squared. Right, so that's the formula that I gave you guys up here. All right, so a difference of cubes is the first minus the second times the first squared plus them two multiplied together plus the second squared. All right, looking on to the next one. This is a sum of cubes. So here I'll leave it, can we see that? Yeah, that'll be okay. So, because this is x cubed plus 3 cubed, so I have x plus 3 times x squared minus 3x plus 9. That's it. If you practice the formula, it's easy money. Right? So keep the sign the same. First term plus the second times the first term squared. Change the sign, so minus now. Them two terms multiplied by each other, that's proper English, plus the second term squared. Here, this is x cubed minus 4 cubed, so x minus 4 times x squared plus 4x plus 16. Easy money. All right, this is x cubed plus 6 cubed. Some of the numbers get big. Remember, you have a calculator, so you can check it in your calculator and make sure that it actually is that thing cubed. It's like 6 cubed. I know that off the top of my head because I'm a weirdo. 6 raised to the third is 216. All right, so if you're ever not sure, just check in your calculator. All right, so if we have x cubed plus 6 cubed, it's falling under the sum one. So I'll keep the sign the same. So I'll have x plus 6 and x squared minus 6x plus 36. There it is. All right, that's pretty much all the factoring for this stuff. This was just special cases. So we'll get to some later on. We're going to be starting to solve quadratics and do other cool stuff with it. We'll get to some where we're not going to always have a special case, and we have some different options into solving. All right, hopefully this video was helpful. Thanks, it's been the shortest one all semester. All right, I'll talk to y'all soon. Let me know what I can do to help you out. Bye!